heap element, it'll use this value as a cookie. So when it's going through this leftmost, so if IBM were to fix this, if you're going through the leftmost or rightmost process, you would ensure that this cookie also matches. So the negative part is it makes it a little bit bigger, but the good part of it is you can't just blindly overwrite stuff and then finally come to it. So another funny thing would be is if IBM AIX put the cookie at the end of it, we would all laugh. So the idea is to put it at the very beginning, so that way everybody knows. I kind of made myself laugh there because if they did that, I would seriously lull. Because then you could just do a partial overwrite and go, okay, yay. Another good example of that, so in relation to that, so when they were first messing with stat cookies and they put the stat cookie in between EBP and the return to EIP, so once again going back to x86, you could overwrite EBP and take control that way, and partial overwrites, everybody loves a partial overwrite, you don't have to do the full overwrite, so you can take advantage of the existing stuff. So as I mentioned, our fake frame is a little bit smaller than what we were required in the last methodology. All we need is the location of our shellcode, and the same size has to matter. So location of the function pointer minus 12 bytes. Once again, can't do math, but we'll figure it out, right? So here's a major difference. So I mentioned earlier I felt like it was necessary to document this. One of the differences is while we're able to take advantage of all sorts of fun things involving different pointers all over the place, I found that when we're corrupting it using leftmost, we're corrupting the heap structure, it really does not like that. And if you go just a little bit further, it will really crap out and hate you. So in order to actually take control of code execution and not make it segfault somewhere else where we have to go around and start repairing the heap and things like that, which can be pretty tedious and pain and sometimes non-accomplishable. So the idea is we got to focus on that return pointer on the stack. You know, typically I pick 1 or 2 away from the original function. You can't get it, let it get back to the original malloc, otherwise it's going to go, oh my god, no. So here's a stack trace. So GDB, yay. You'll see that malloc is called. Let me back up. So you'll see the shr.o. So apparently it's shr.c if I had to guess, that controls the heap algorithm. So when malloc's called, malloc actually calls another malloc, which is a generic handler. And then from there, it actually calls something called malloc y, which I don't know what it is, but I can't wait to find out. I actually have done enough reversing on the entire heap algorithm, like our previous speaker, who spent the entire year doing it, and I'm jealous because I wish I had fun things to do like that, and I actually have to do other work for customers. So, and then we get to leftmost. And once again, leftmost's responsibility and rightmost's responsibility is to walk this double linked list and find when the heap sizes change, the heap element sizes change, and then it's going to go, okay, let's stick it there. Once again, really bad coder. Me, not everyone else. I'm a really bad coder. And you'll see that I've allocated 20 bytes, and it's going to give me a heap element of 20 bytes. And then what I'm going to do, ignorantly, is I'm going to use string copy, which we've all seen that. And everybody knows not to do that, right? All right. And then we're going to allocate some more memory. And so obviously, because this is kind of fake code, it doesn't really make sense. But in typical environments, I oftentimes see more mallocs occur. Excuse me. I'm sorry. More mallocs occur than in a row than I do malloc in a free that's lined up. Well, they do exist, but I found in my test cases it tends to lean towards using leftmost more versus using rightmost. So when we malloc once again, then it's going to walk it left, and then that's when we're going to use this methodology. So what I feel like I've provided is the all-encompassing way of owning AIX Heap, because the Litchfield methodology in 2005 was published, and he conquered half of it. But there's this other section over here, and I've actually, so in 2006 or 2007, Intrepid, which is with CAU, Maybe you've seen him. He runs around with a green guy named Druid. Anybody seen a green guy? Yeah, we all like the green guy. They found an AIX bug that was set UID something worthless. Actually, it was like set GID something pretty worthless. So they just said, okay, here, forget it. It's not worth anything. So here's how you do it, and then here's all the entire output. And so the reason I know that this exists is because I started Googling leftmost, rightmost, and I found his advisory. But he didn't have any code execution or any any example exploit that showed you actually how to do it. It just showed you how to trigger the bug. So I'm making a huge assumption, but I think either A, he just didn't want to publish, which that's typically not how those guys roll, or B, he just didn't know how, or C, it was worthless once again, and who cares? So it's got to be one of those. So when we're adding an entry, as I mentioned, we were going to go to the furthest heap entry on the left that matches in size, and then we're going to insert this new element in the double linked list. So the heap algorithm needs to know the first entry so it can keep it contiguous and packaged well, and we're not having a bunch of gaping holes in heap, and it can help manage it a little bit better. Oh great, live. So you see I say live demo, but it's in parentheses pre-recorded. There are two reasons. One, like I mentioned, I'm not going to point, sorry. Somebody did a presentation yesterday, and they had some issues with their demo, and that's the last thing that I want. And two, I hear this is called Black Hat, and it doesn't make sense for me to get on any sort of network here, VPN into our own network, which, got to be quite honest, I don't feel like we're as secure as we need to be, and then do a live demo. So part of that gives me the willies. And actually I saw Twitter earlier that they said, if I hear someone else complain about not wanting to use the network because they feel like they're going to get owned, I'm going to shoot them. Well, I hope you're here at the talk, because you can hit me up later. I know who you are, I don't see you, so. Which, thanks for being a great friend. Okay, so what we're going to do, pause it there. So what we're going to do is I'm basically going to go through of what the an example exploit looks like. Our vulnerable function, or I'm sorry, our vulnerable binary is called /leftmost. So this, once again, it's just a basic, generic, let's show you the methodology. This is not a unique bug. All right. We can also ignore the shellcode because, so there's a side note also. I found a lot of the new shellcode for AIX doesn't work anymore for whatever reason. So in my research, I've actually had to end up creating my own shellcode that maybe one day I'll create some more and we can give it to HC Morris so they can use it. But right now they're using the same basic 3 different shellcodes that have been published since like 2000 for AIX, and nobody's really messed with it since. And so some of the stuff they're doing doesn't really work anymore. And that's kind of sad. It also tells me that nobody's looking at AIX anymore. So, going back to, I feel like there's people out there that use AIX. Some days I don't feel like I'm getting the affirmation, but I know in the environment that I'm in, that's a true statement. In fact, when I've been talking to people about my talk, so I knew this was going to happen. I knew last day, I'm going to have 8 people in the room. Great. So I've been running around everywhere going, go to my talk. And they're like, well, what's it on? I'm like, well, it's on AIX. I either get the answer, well, who the heck uses that? Or, oh, everybody uses that. That'd be great. And then both those people that have said those things, I see none of them in here. So, oh, yeah, y'all don't count. Y'all don't count. You're my friend, I think, so it doesn't count. All right, so we'll let this run through a little bit. You'll see that a few things that need to be pointed out. Well, first, because this is just an example, what I'm going to do is I'm actually going to run GDB to show you. So I'm not going to just like / and there comes a prompt, because how can you prove that I didn't fake all that anyway? And the entire thing is just supposed to, like the leftmost is actually just a wrapper to like a shell. So, which I can't imagine anybody faking a demo, but I've heard it's happened before. So I want to make sure everybody knows I'm semi-full of stuff, but not completely full, right? Okie doke. So, what we're going to do is, I think it's 20 bytes. We're going to overflow with A's, as you can see here. And we're going to overwrite the next heap element header with, so the variable is called R7, and the reason that is actually R7 is the register that's being used as a reference. So when I'm just going through this stuff, and I found that R7 wasn't used in some of the other areas, so it was just easy to just call it R7, and then that way everybody knows. And then the next is going to be our size. So once again, Litchfield's methodology doesn't require the size to be anything unique. It just has to match. But in this methodology, that is exactly what we're doing to overwrite something. So we need that to be a useful value. I'll let that keep going there. So you'll see I highlight it once again. R7 points to our fake frame in memory, which our fake frame is actually right here. I'm putting it in the environment for this example. And so now that is our function pointer that we want to overwrite that's stored on the stack through our return address, minus 12 bytes. And then our size, so once again, as I mentioned, I feel like I could actually use the shellcode location, but I figured I'd use one of those magic values, 31337 0C, to show you that PC, which is similar to, is the same as EIP or IPs, is going to contain our new value. So that would be kind of the similar way of like, oh look, it's 41, 41, 41, 41. Yeah, great. So another key thing is, I'm not sure everybody knows, if you're not familiar with PPC or any other type of RISC architecture, but it's got to be 4-byte aligned. So I couldn't do something like dead beef. I couldn't do Cafe Babe. I couldn't do some of the, Xerox 41 because they're not 4-byte aligned, and it's going to look kind of goofy. So I made sure that this was 4-byte aligned and made it happen. So we'll keep going here. So our environment contains the same size. Whoop, that happened fast. Our environment contains the same size, which is our location. Let's see. No, I'm sorry. Yeah, that's right. And then we'll // Everybody loves a // and run it. Bam. So 31337 0C, which obviously is an invalid address and doesn't exist, and that's why GDB is complaining. Just kidding. I love it when speakers require the applause because apparently I'm putting everybody to sleep. So a few other tips. Actually, I'm going to read my hand because I wrote some stuff. I had jokes that I was going to add. Oh, here's one. Does Caesar still live here? I can't find his room. Oh, yeah, that's it. Dang it. So a few fun little tips that'll help when you're actually going through the process of hunting for 0 day on the heap. I didn't know this until I read Litchfield's paper, but there are actually a few environment variables that we can utilize that will allow us to kind of have a better understanding of what's going on. And by having a better understanding of what's going on and changing some stuff, we actually get a lot of great debugging output, which everybody loves debugging output because, they provided it for us, right? One of them, so this actually used to be a bug. When Litchfield started using this, he realized, oh, by the way, it'll overwrite anything you want, and it just so happens to give special permissions. So you could corrupt all sorts of fun files with heap output. So for example, if you read a set UID binary with this environment variable, it's going to, excuse my terminology, crap out a bunch of debugging information. So if you overwrote a password file or something in security or what have you, so if you could control it, that'd be even better. But so, and AIX, the IBM AIX guys